Hi everyone, welcome to the fourth session of logistic regression. In this session, we will learn about the mathematics behind the logistic regression. Suppose we have a data set from an online XYZ store about the gender of customer and whether that person bought a particular product or not. We are interested in finding the chances of a customer buying that product given their gender. So what comes to the mind when someone poses this question to you? The skill required will be like probability or the odds of success or even the odds of failure. So just think a bit, what will really require to solve this? So before proceeding forward, I just like to show you the data set. We have the gender CSV and this is nothing but it has two columns. The first column is the gender, male or female, and the second column shows it shows basically whether the person is purchasing, that gender is purchasing, yes or no. Now what we'll do, we will create a contingency table. So now what we'll do, we'll create a contingency table and find out the data, how the data looks like. So for that we will use the pandas cross tab. So in this case we can see that 106 females and 125 males have not purchased, while 159 females and 121 males have purchased the item. Now we will further do some more calculation and based on the sum wise. Like we can see that for axis 1, if you can see, if you add up these two columns, so we can see when we have done this, we can see this is nothing but a total number of females and this is nothing but a total number of males. Okay, so there are total 265 males and total 246 males, and if we execute this based on the axis, it will give us the total number of purchased items is 280 and the total number of not purchased is 231. It includes both males and females, and we will execute one last line of code here in this video which will not which will show that we will try to calculate a proportion of males and females who have purchased and who did not purchase a particular product. So now this is our baseline. This is this gender purchase, whatever is here, this is our base for the entire video that will work on. Okay, so we'll go back to our presentation. What is the probability of a customer buying a product given she is a female, and then what is the probability of a customer buying the product given he is a male? Now if we know the answers to this question, it will really help us in predicting the chances of a customer buying the product given their gender. Let's have some probability refreshment, where we can say that the probability of an event A occurring is nothing but the number of ways an event can occur divided by total number of possible outcomes. So in our case, let's take an example of the fair coin flip. The probability of getting head is 1 by 2 and also the probability of getting tail is 1 by 2. Similarly, let's take one more example of rolling a fair die. The probability of getting 1 or 2 or 3 or 4 or 5 or 6 is 1 by 6 because it's a fair die. In case of probability of getting 1 or 2 will be, it will be like there how many outcomes, 1 or 2, right? So 2 outcomes divided by total number of outcomes, right? So 2 by 6, this is 1 by 3. Again, the probability of getting 1 or 2 or 3 will be total number of ways the event can occur is 3. 3 divided by total number of outcomes is 6, right? So 3 by 6 is nothing but 1 by 2. 3 by 6 is nothing but 1 by 2. Now we'll go to the next example, which is playing a deck of cards. So in the card, we know there are 52 cards and there will be 4 varieties of card: club, heart, spade and diamond. Each will be 13. So the probability of getting a heart card is nothing but 13 by 52, which is 1 by 4 or 0.25. Also, let's have some refreshment on conditional probability. Well, the conditional probability basically defines the probability of a certain event happening given that a certain related event is true or already has happened. So in our case of purchase, in our case of the example in Python editor which I have shown you, the probability of purchase by female is nothing but a total number of purchase by female divided by total number of females in the group. Okay, total number of item purchased by male divided by total number of males in the group. So if we calculate the conditional probability here, it will be, you can see here, this is my initial table. This, so purchase by female will be total number of purchase by female, which is how much? Total number of purchase by female is 159, right? Divided by total number of females is 265. Add these two, yes and no, then this will give you 265, right? Similarly, total probability of not purchase given it's a female is 106, it is 106 by 265, or alternatively you can say 1 minus 159 by 265. Okay, this will be equals to 265 minus 159 by 265, and this will be equals to 106 by 265, and it is 0. After rounding it's 0.4. Similarly, probability of purchase of an item even it's a male is 121 by 246, and also the probability of not purchase of an item given it's a male is 121 by 246. Alternatively, we can say 1 minus 121 by 246, which is equal to 0.51. Please post a message if you are not able to understand this. I hope this is very clear and you'll be able to understand. Let's learn something about the odd ratio. Okay, so the odds is nothing but a probability of something occurring, some event occurring, divided by the probability of something not occurring. So the odds is, so we can say that, so if the probability of certain event occurring is p, then the odds will be p by 1 minus p. So this is event occurring and this is not occurring. This is not occurring and this is occurring. Let's take an example of the fair coin flip. Okay, the odds of getting tail will be the event, it means the probability of the event happening, which is 0.5 by 1 minus 0.5, which is equal to 0.5 by 0.5. Okay, and this is nothing but it's equal to 1 or 1:1. Again, let's take an example of the fair die roll. In case of this fair die roll, this example of a fair die roll, the odds of getting 1, okay, because of fair die, odds of getting 1 will be how much? 1 by 6 divided by 1 minus 1 by 6. This 1 minus 1 by 6, that is the formula for odds. P by probability of that event happening by 1 minus the same probability of that event. So this will be 1 by 6 by 5 by 6, and this is nothing but 1:5. Now the probability of getting 1 or 2 will be, now the total outcomes 1 or 2 will be 2 by 6 divided by 1 minus 2 by 6, and this will be 2 by 6 by 4 by 6. This 2 will cut off, and then you get 2 by 4, which is 1 by 2 or 0.5 or 1:2. Okay, similarly the probability of getting 1 or 2 or 3 will be 3 by 6 by 1 minus 3 by 6. This is nothing but 3 by 6 by 3 by 6. These two will cancel out each other. This will be 1 by 1 or 1:1. Okay, odds ratio is a ratio of odds of success purchase, in this case for each group, male and female in our case. Now also the odds of success for a group are defined as a ratio of probability of success to the probability of failure. Okay, in our case, the odds of the purchase for the group of males and female can be defined as follows. So we can say the odds of purchase by females is probability of purchase by female is PF is nothing but the probability of purchase by female. So PF by 1 minus PF. And similarly, the probability P suffix M is nothing but the probability of purchase by male. So the odds of purchase by male is equals to probability of purchase by male by 1 minus probability of purchase by male. So we know from our contingency table calculation, the probability of purchase by male is 121 by 246, and the probability of purchase by female is 159 by 265. So you can say here probability of purchasing by female is 159 by total this, and probability of purchase by male is 129 by total this, right? So the odds of purchase by female will be how much? PF by 1 minus PF. When we insert the value here, it will be 1 by 159 by 265 divided by 1 minus 159 by 265, and this will be equals to when you do this will cancel out each other, and this will be 159 by 106. Okay, now similarly the odds of purchase by male will be PM by 1 minus PM, where PM is nothing but the probability of purchase by male, and the probability of purchase by male is 121. This is 121 by 246. So the moment you enter the value here, this PM is 121 by 246, and this value here is this 1 minus 121 by 246. So this will be 121 by 246 divided by 125 by 246. These two cancel each other, and this will be 121 by 125. That is the odds of purchase by male. So we know the odds of purchase by female and the odds of purchase by male, which is 159 by 106 and 121 by 125. So if we analyze it properly, we can say the odds of success of female is nothing but the number of success in that group. So if n suffix s is the number of success in that group, then we can say the odds of success of female is number of success for female by number of failure. FF is failure for female. Similarly, odds of success for male will be number of success for males. This is success and this is males. Okay, so number of success for males divided by number of failure. F is failure for males. So we can say similarly for this is success for females and this is failure for, and this is females. We will come back on this in our next slide. So before that, we will discuss a few points about the odds of an event. Now, if the odds of success for a group is more than 1, then it is more likely for that group to be successful. The higher the odds, the better is the chance of success. Now, if the odds of success is less than 1, then it is more likely to get failure. The lower the odds, the higher the chance of failure. And the odds can range from 0 to infinity. So these 3 points are quite important. Now coming to our gender purchase example, well, the odds of success is greater than 1 for females and less than 1 for males. Thus we can conclude that females have a better chances of success in this case. So we can stop here, right? In the business term, if you want to talk, you need to come up with the exact number. So that's what we need to come. How much time females group is better in purchasing than the males group? So this is how what we will do now. One better way to determine which group has better odds of success is by calculating the odd ratio of each group. And that's what I am talking about. The odd ratio is defined as the odds of success in group 1 by the odds of success in group 2. So the odd ratio is nothing but for the, if you see here, males and the female group will be, suppose, so this is nothing but probability of success for male divided by the 1 minus probability of success for males divided by probability of success for female divided by 1 minus probability of success for males. So this can be alternatively written as odd ratio is equals to number of success for males divided by number of failure for females. S is success and F is failure. Here also divide by number of success for females divided by number of failure for females. And alternatively can say that odd ratio for females group is odd ratio for females is equal to odd of success for females by divided by odd of success for males. This can be written as 159,106 divided by, and this will give you 1.54, right? This value. Similarly, the odd ratio for males is nothing but the odds of success for males divided by odd of success for females. And in this case, it will come up to 0.64. Okay, so we can say that the odd ratio for female is much better than the odd ratio for males. Few points to be noted about this odd ratio. Well, we can see here that the more the odd ratio, the more the chances of success from that group. In our case, the female group has an odd ratio of 1.24, which means it is more probable to get success from a purchase example than the male customer. Well, if the odd ratio is equal to 1, then there is no association between the two groups. This is very important. You need to remember this. Also, if the odd ratio is greater than 1, then the event is more likely to happen in group 1. And if the odd ratio is less than 1, then the event is more likely to happen in group 2. Also, the odd ratio for one group can be obtained by taking the reciprocal of the odd ratio of the other group. That's what we have taken here. So our final conclusion is odd of purchase of item by female group is 1.4 times greater than male group. That's it for this session. In this session, I have shown you the importance of contingency table, how we'll get the summation of the total number of males and females using the Python code, and also I have shown you the probability, just given the very basics of probability, the probability and the conditional probability refresher followed by the odds ratio. And again, I have shown you the important points about the success and failure, and also odd ratio as a group of odds of success in group 1 with respect to group 2. Also, I have shown you the important point, the value of odd. If odd is equals to 1, then there is no association. If what happened if it is greater than 1, what if happened if it less than 1. Then finally we concluded that odds of purchase of item by female group is 1.4 times greater than male group. But why we are doing all this? Where do we apply this? This is no way related to logistic regression, right? Exactly. In my next video, I will show you how odds finds its application with the logistic regression equation. And that is why I wanted to give you a in-depth intuition of probability, conditional probability, odds, and also the understanding of the value of odds. So thanks a lot for watching this session. If you feel this video is helpful, please press the like button and subscribe to this channel, and also if possible, please share my video with your friends. And I'm already done with my next video on how to derive the logistic regression that I will be sharing by tomorrow. That will be the New Year gift. So I will see you in my next video. Thank you.